Holocene extinction. An artscape image showing the relative importance of animals in a rainforest through a summary of a child's perception compared with b a scientific estimate of the importance. The size of the animal represents its importance. Child's mental image places importance on big cats, birds, butterflies, and then reptiles versus the actual dominance of social insects such as ants. Conservation biologists are dealing with and have published evidence from all corners of the planet indicating that humanity may be causing the sixth and fastest planetary extinction event. 136, 137, 138, it has been suggested that an unprecedented number of species is becoming extinct in what is known as the Holocene extinction event. 139, the global extinction rate may be approximately 1,000 times higher than the natural background extinction rate. 140, it is estimated that 2/3 of all mammal genera and 1/2 of all mammal species weighing at least 44 kilograms, 97 pounds, have gone extinct in the last 50,000 years. 130, 141, 142, 143, the Global Amphibian Assessment, 144 reports that amphibians are declining on a global scale faster than any other vertebrate group, with over 32% of all surviving species being threatened with extinction. The surviving populations are in continual decline in 43% of those that are threatened. In the mid-1980s, the actual rates of extinction have exceeded 211 times rates measured from the fossil record. 140, however, the current amphibian extinction rate may range from 25,039 to 45,474 times the background extinction rate for amphibians. 145, the global extinction trend occurs in every major vertebrate group that is being monitored. For example, 23% of all mammals and 12% of all birds are red listed by the International Union for Conservation of Nature, IUCN, meaning they too are threatened. With these predictions will undoubtedly appear extreme, but it is difficult to imagine how such changes will not come to pass without fundamental changes in human behavior. J.B. Jackson, 17, 11463. Extinction. Even though the decline in species is happening at such an incredible rate that evolution can simply not match, therefore, leading to the greatest continual mass extinction on Earth. 146, humans have dominated the planet and our high consumption of resources, along with the pollution generated, is affecting the environments in which other species live. 146, 147, there are a wide variety of species that humans are working to protect, such as the Hawaiian crow and the whooping crane of Texas. People can also take action on preserving species by advocating and voting for global and national policies that improve climate, under the concepts of climate mitigation and climate restoration. Earth's oceans demand particular attention as climate change continues to alter pH levels, making it uninhabitable for organisms with shells which dissolve as a result. 140. Status of oceans and reefs. Global assessments of coral reefs of the world continue to report drastic and rapid rates of decline. By 2000, 27% of the world's coral reef ecosystems had effectively collapsed. The largest period of decline occurred in a dramatic, bleaching, event in 1998, where approximately 16% of all the coral reefs in the world disappeared in less than a year. Bleaching is caused by a mixture of environmental stresses, including increases in ocean temperatures and acidity, causing both the release of symbiotic algae and death of corals. 149, decline and extinction risk in coral reef biodiversity has risen dramatically in the past 10 years. The loss of reefs, which are predicted to go extinct in the next century, threatens the balance of global biodiversity, will have huge economic impacts, and endangers food security for hundreds of millions of people. 150, conservation biology plays an important role in international agreements covering the world's oceans, 149, and other issues pertaining to biodiversity. The oceans are threatened by acidification due to an increase in CO2 levels. This is a most serious threat to societies relying heavily upon oceanic natural resources. A concern is that the majority of all marine species will not be able to evolve or acclimate in response to the changes in the ocean chemistry. 151. The prospects of averting mass extinction seems unlikely when 90% of all of the large, average approximately as greater than or equal to 50 kilogram, open ocean tuna, bill fishes, and sharks in the ocean, 17, are reportedly gone. A scientific review of current trends, the ocean is predicted to have few surviving multicellular organisms with only microbes left to dominate marine ecosystems. 17. Groups other than vertebrates. Serious concerns also being raised about taxonomic groups that do not receive the same degree of social attention or attract funds as the vertebrates. These including lichen-forming species, 152, invertebrate particularly insect, 15, 153, 154, and plant communities, 155, where the vast majority of biodiversity is represented. Conservation of fungi and conservation of insects, in particular, are both of pivotal importance for conservation biology. As mycorrhizal symbionts, and as decomposers and recyclers, fungi are essential for sustainability of forests. 152, the value of insects in the biosphere is enormous because they outnumber all other living groups in measure of species richness. The greatest bulk of biomass on land is found in plants, which is sustained by insect relations. This great ecological value of insects is countered by a society that often reacts negatively toward these aesthetically unpleasant creatures. 156, 157. One area of concern in the insect world that has One area of concern in the insect world that has caught the public eye is the mysterious case of missing honeybees, Apis mellifera. Honeybees provide an indispensable ecological services through their acts of pollination, supporting a huge variety of agriculture crops. The use of honey and wax have become vastly used throughout the world. 158. The sudden disappearance of bees leaving empty hives or colony collapse disorder, CCD, is not uncommon. However, in a 16-month period from 2006 through 2007, 29% of 577 beekeepers across the United States reported CCD losses in up to 76% of their colonies. This sudden demographic loss in bee numbers is placing a strain on the agricultural sector. The cause behind the massive declines is puzzling scientists. Pests, pesticides, and global warming are all being considered as possible causes. 159, 160. Another highlight that links biology to insects, forests, and climate change is the mountain pine beetle Dendroctonus ponderosae epidemic of British Columbia, Canada, which has infested 470,000 square kilometers, 180,000 square miles of forested land since 1999. Adaptation biology to insects, forests, and climate change is the mountain pine beetle Dendroctonus ponderosae epidemic of British Columbia, Canada, which has infested 470,000 square kilometers, 180,000 square miles of forested land since 1999. An 106 an action plan has been prepared by the government of British Columbia to address this problem. 161, 162. This impact pine beetle epidemic converted the forest from a small net carbon sink to a large net carbon source both during and immediately after the outbreak. In the worst year, the impacts resulting from the beetle outbreak in British Columbia were equivalent to 75% of the average annual direct forest fire emissions from all of Canada during 1959–1999. Kurz et al., 107. Human activities are associated directly or indirectly with nearly every aspect of the current extinction spasm. Waken. Vredenberg, 136. Conservation biology of parasites. A large proportion of parasite species are threatened by extinction. A few of them are being eradicated as pests of humans or domestic animals, however, most of them are harmless. Parasites also make up a significant amount of global biodiversity, given that they make up a large proportion of all species on Earth, 163, making them of increasingly prevalent conservation interest. Threats include the decline or fragmentation of host populations, 164, or the extinction of host species. Threats are intricately woven into ecosystems and food webs, thereby occupying valuable roles in ecosystem structure and function. 165, 163. Threats to biodiversity. Today, many threats to biodiversity exist. An acronym can be used to express the top threats of present day. HIPPO stands for habitat loss, invasive species, pollution, human population, and overharvesting. 66. The primary threats. Today, many threats to biodiversity exist. An acronym that can be used to express the top threats of present day. HIPPO stands for habitat loss, invasive species, pollution, human population, and overharvesting. 166. The primary threats to biodiversity are habitat destruction, such as deforestation, agricultural expansion, urban development, and overexploitation, such as wildlife trade. 100. One hundred 167. 175. A significant consequence of fragmentation and lack of linked protected areas is the reduction of animal migration on a global scale. 100. Considering that billions of tons of biomass are responsible for nutrient cycling across the Earth, the reduction of migration is a serious matter for conservation. Biology. 177, 178. However, human activities need not necessarily cause irreparable harm to the biosphere. With management and planning for biodiversity at all levels, from genes to ecosystems, there are examples where humans mutually coexist in a sustainable way with nature. 179. Even with the current threats to biodiversity, there are ways we can improve the current condition and start anew. Many of the threats to biodiversity, including disease and climate change, are reaching inside borders of protected areas, leaving them not so protected, e.g. Yellowstone National Park. 180. Climate change, for example, is often cited as a serious threat in this regard, because there is a feedback loop between species extinction and the release of carbon dioxide into the atmosphere. 106. 107. Ecosystems store and cycle large amounts of carbon, which regulates global conditions. 181. In present day, there have been major climate shifts with temperature changes making survival of some species difficult. 166. The effects of global warming add a catastrophic threat toward a mass extinction of global biological diversity. 32. Numerous more species are predicted to face unprecedented levels of extinction risk due to population increase, climate change and economic development in the future. 183. Conservationists have claimed that not all the species can be saved, and they have to decide which their efforts should be used to protect. This concept is known as the conservation triage. 186. The extinction threat is estimated to range from 15 to 37% of all species by 2050, 182 or 50% of all species over the next 50 years. 15. The current extinction rate is 100,000 times more rapid today than the last several billion years. 166. Applied ecology. Biodiversity loss. Biodiversity loss happens when plant or animal species disappear completely from Earth, extinction, or when there is a decrease or disappearance of species in a specific area. Biodiversity loss means that there is a reduction in biological diversity in a given area. The decrease can be temporary or permanent. It is temporary if the damage that led to the loss is reversible in time, for example through ecological restoration. If this is not possible, then the decrease is permanent. The cause of most of the biodiversity losses, generally speaking, human activities that push the planetary boundaries too far. 3. These activities include habitat destruction, for example deforestation, and land use intensification, for example monoculture farming. 5. 6. Further problem areas are air and water pollution, including nutrient pollution, overexploitation, invasive species, 7, and climate change. 4. Summary of major environmental change categories that cause biodiversity loss. The data is expressed as a percentage of human-driven change, in red, relative to baseline, blue, as of 2021. The data is expressed as a percentage of human-driven change, in red, relative to baseline, blue, as of 2021. Red indicates the percentage of the category that is damaged, lost, or otherwise affected, whereas blue indicates the percentage that is intact, remaining, or otherwise unaffected. 1. Many scientists, along with the Global Assessment Report on Biodiversity and Ecosystem Services, say that the main reason for biodiversity loss is a growing human population because this leads to human overpopulation and excessive consumption. Many scientists, along with the Global Assessment Report on Biodiversity and Ecosystem Services, say that the main reason for biodiversity loss is a growing human population because this leads to human overpopulation and excessive consumption. 8, 11, 12 Others disagree, saying that loss of habitat is caused mainly by the growth of commodities for export, and that population has very little to do with overall consumption. More important are wealth disparities between and within countries. 13. Climate change is another threat to global biodiversity. 14. Example, coral reefs, which are biodiversity hotspots, will be lost by the year 2100 if global warming continues at the current rate. 16. 17. Still, it is the general habitat destruction, often for expansion of agriculture, not climate change, that is currently the bigger driver of biodiversity loss. 18. 19. Invasive species and other disturbances have become more common in forests in the last several decades. These tend to be directly or indirectly connected to climate change and can cause a deterioration of forest ecosystem. 2021. Groups that care about the environment have been working for many years to stop the decrease in biodiversity. Nowadays, many global policies include activities to stop biodiversity loss. For example, the UN Convention on Biological Diversity aims to prevent biodiversity loss and to conserve wilderness areas. However, a 2020 United Nations Environment Program report found that most of these efforts had failed to meet their goals. For example, of the 20 biodiversity goals laid out by the Aichi biodiversity targets in 2010, only 6 were partially achieved by 2020. 23-24 This ongoing global extinction is also called the Holocene extinction or sixth mass extinction. Global estimates across all species. Red list categories of the IUCN. Demonstrator against biodiversity loss, at Extinction Rebellion 2018. The rate of global biodiversity loss is estimated to be 100 to 1,000 times higher than the naturally occurring background extinction rate, faster than at any other time in human history. 25-26. The current rate of global biodiversity loss is estimated to be 100 to 1,000 times higher than the naturally occurring background extinction rate, faster than at any other time in human history, 25-26, and is expected to grow in the upcoming years. 29. The fast-growing extinction trends of various animal groups like mammals, birds, reptiles, amphibians, and fish have led scientists to declare a current biodiversity crisis in both land and ocean ecosystems. 30. In 2006, many more species were formally classified as rare or endangered or threatened. Moreover, scientists have estimated that millions more species are at risk that have not been formally recognized. 32. Deforestation also plays a large role in biodiversity loss. More than half of the world's biodiversity is hosted in tropical rainforest. 33. Regions that are subjected to exponential loss of biodiversity are referred to as biodiversity hotspots. Since 1988, the hotspots increased from 10 to 34. The total 34 hotspots currently present, 16 of them are in tropical regions, as of 2006. In 2006 that only 2.3% of the world is covered with biodiversity loss hotspots, and even though only a small percentage of the world is covered in hotspots, it hosts a large fraction, 50%, of vascular plant species. 35. 2021, 28% of the 134,400 species assessed using the IUCN Red List criteria are now listed as threatened with extinction, a total of 37,400 species compared to 16,119 threatened species in 2006. 36. A 2022 study that surveyed more than 3,000 experts found that global biodiversity loss and its impacts may be greater than previously thought, and estimated that roughly 30% of species have been globally threatened or driven extinct since the year 1500. 37-38. Research in 2023 found that, out of 70,000 species, about 48% are facing decreasing populations due to human activities, while only 3% are seeing an increase in populations. 39-40-41. Methods to quantify loss. Biologists define biodiversity as the totality of genes, species and ecosystems of a region. 42-43. To measure biodiversity loss rates for a particular location, scientists record the species richness and its variation over time in that area. In ecology, local abundance is the relative representation of a species in a particular ecosystem. 44. It is usually measured as the number of individuals found per sample. The ratio of abundance of one species to one or multiple other species living in an ecosystem is called relative species abundance. 44. Both indicators are relevant for computing biodiversity. There are many different biodiversity indexes. 45. These investigate different scales and time spans. 46. Biodiversity has various scales and subcategories, e.g. phylogenetic diversity, species diversity, genetic diversity, nucleotide diversity. 46. The question of net loss in confined regions is often a matter of debate. 47. Observations by type of life. Wildlife in general. The World's Living Planet Report 2022 found that wildlife populations declined by an average 69% since 1970. 48, 49, 50. An October 2020 analysis by Swiss Re found that 1/5 of all countries are at risk of ecosystem collapse as a result of anthropogenic habitat destruction and increased wildlife loss. 51. If these losses are not reversed, a total ecosystem collapse could ensue. 52. The World Wildlife Fund reported 53 an average population decline of 68% between 1970 and 2016 for 4,400 animal species worldwide, encompassing nearly 21,000 monitored populations. 54. Terrestrial invertebrates. Insects. Annual decline of 5.2% in flying insect biomass found in nature reserves in Germany, about 75% loss in 26 years. 55. Insects are the most numerous and widespread class in the animal kingdom, accounting for up to 90% of all animal species. 56-57. In the 2010s, reports emerged about the widespread decline in insect populations across multiple insect orders. The reported severity shocked many observers, even though there had been earlier findings of pollinator decline. There has also been anecdotal reports of greater insect abundance earlier in the 20th century. Many car drivers know this anecdotal evidence through the windscreen phenomenon, for example. 58-59. Causes for the decline in insect population are similar to those driving other biodiversity loss. Habitat destruction, such as intensive agriculture, the use of pesticides, particularly insecticides, introduced species, and, to a lesser degree and only for some regions, the effects of climate change. 60. An additional cause that may be specific to insects is light pollution. Research in that area is ongoing. 61, 62, 63. Most commonly, the declines involve reductions in abundance, though in some cases entire species are going extinct. The declines are far from uniform. In localities, there have been reports of increases in overall insect population, and some types of insects appear to be increasing in abundance across the world. 64. Not all insect orders are affected in the same way. Most affected are bees, butterflies, moths, beetles, dragonflies and damselflies. Many of the remaining insect groups have received less research to date. Also, comparative figures from earlier decades are often not available. 64. In the few major global studies, estimates of the total number of insect species at risk of extinction range between 10% and 40%, 65, 60, 66, 67, though all of these estimates have been fraught with controversy. 68, 69, 70, 71. Earthworms. Earthworm on plant. Scientists have studied loss of earthworms from several long-term agronomic trials. Found that relative biomass losses of -50–100%, with a mean of -83%, match or exceed those reported for other faunal groups. 72. Thus it is clear that earthworms are similarly depleted in the soils of fields used for intensive agriculture. 70. Earthworms play an important role in ecosystem function. 72. Helping with biological processing in soil, water, and even greenhouse gas balancing. 5 reasons for the decline of earthworm diversity. 1. Soil degradation and habitat loss. 2. Climate change. 3. Excessive nutrient and other forms of contamination load. 4. Overexploitation and unsustainable management of soil. And 5. Invasive species. 70. 26 factors like tillage practices and intensive land use decimate the soil and plant roots that earthworms use to create their biomass. 74. This interferes with carbon and nitrogen cycles. Knowledge of earthworm species diversity is quite limited as not even 50% of them have been described. 73. Sustainable agriculture methods could help prevent earthworm diversity decline, for example reduced tillage. 73. 32. The Secretariat of the Convention on Biological Diversity is trying to take action and promote the restoration and maintenance of the many diverse species of earthworms. 73. Amphibians. Golden toad of Monteverde, Costa Rica, was among the first casualties of amphibian declines. Formerly abundant, it was last seen in 1989. Since the 1980s, decreases in amphibian populations, including population decline and localized mass extinctions, have been observed in locations all over the world. This type of biodiversity loss is known as one of the most critical threats to global biodiversity. The possible causes include habitat destruction and modification, diseases, exploitation, pollution, pesticide use, introduced species, and ultraviolet B radiation (UVB). However, many of the causes of amphibian declines are still poorly understood, and the topic is currently a subject of ongoing research. Modeling results found that the current extinction rate of amphibians could be 211 times greater than the background extinction rate. This estimate even goes up to 25,000–45,000 times if endangered species are also included in the computation. 75. Wild mammals. Biomass of mammals on Earth as of 2018, 76–77. Livestock, mostly cattle and pigs, 60%. Humans, 36%. Wild mammals, 4%. The decline of wild mammal populations globally has been an occurrence spanning over the past 50,000 years, at the same time as the populations of humans and livestock have increased. The total biomass of wild mammals on land is believed to be 7 times lower than its prehistoric values, while the biomass of marine mammals had declined 5-fold. The biomass of humans is an order of magnitude higher than that of all wild mammals, and the biomass of livestock mammals like pigs and cattle is even larger than that. Even as wild mammals had declined, the growth in the numbers of humans and livestock had increased total mammal biomass 4-fold. Only 4% of that increased number are wild mammals, while livestock and humans amount to 60% and 36%. Alongside the simultaneous halving of plant biomass, these striking declines are considered part of the prehistoric phase of the Holocene extinction. Since the second half of the 20th century, a range of protected areas and other wildlife conservation efforts, such as the repopulation of wolves in Midwestern United States, have been implemented. These have had some impact on preserving wild mammal numbers. There is still some debate over the total extent of recent declines in wild mammals and other vertebrate species. 79–80. In any case, many species are now in a worse state than decades ago. 81. Hundreds of species are critically endangered. 82–83. Climate change also has negative impacts on land mammal populations. 78. Birds. Some pesticides, like insecticides, likely play a role in reducing the populations of specific bird species. 84. According to a study funded by BirdLife International, 51 bird species are critically endangered and 8 could be classified as extinct or in danger of extinction. Nearly 30% of extinction is due to hunting and trapping for the exotic pet trade. Deforestation, caused by unsustainable logging and agriculture, could be the next extinction driver, because birds lose their habitat and their food. 85–86. Plants. Trees. While plants are essential for human survival, they have not received the same attention as the conservation of animals. 87. It is estimated that a third of all land plant species are at risk of extinction and 94% have yet to be evaluated in terms of their conservation status. 87. Plants existing at the lowest trophic level require increased conservation to reduce negative impacts at higher trophic levels. 88. In 2022, scientists warned that a third of tree species are threatened with extinction. This will significantly alter the world's ecosystems because their carbon, water and nutrient cycles will be affected. 89–90. Forest areas are degraded due to common factors such as logging, fire, and firewood harvesting. 90. GTA Global Tree Assessment has determined that 17,510, 29.9% tree species are considered threatened with extinction. In addition, there are 142 tree species recorded as extinct or extinct in the wild. 90. Possible solutions can be found in some silvicultural methods of forest management that promote tree biodiversity, such as selective logging, thinning or crop tree management, and clear cutting and coppicing. Without solutions, secondary forests recovery in species richness can take 50 years to recover the same amount as the primary forest, or 20 years to recover 80% of species richness. 93. Flowering plants. Viola calcarata, a species highly vulnerable to climate change. 94. Human impact on the environment has driven a range of species extinct and is threatening even more today. Organizations such as IUCN and Royal Botanic Gardens, Kew suggest that around 40% of plant species are threatened with extinction. The majority are threatened by habitat loss, but activities such as logging of wild timber trees and collection of medicinal plants, or the introduction of non-native invasive species, also play a role. 96, 97, 98. Relatively few plant diversity assessments currently consider climate change. 95, yet it is starting to impact plants as well. About 3% of flowering plants are very likely to be driven extinct within a century at 2 degrees Celsius, 3.6 degrees Fahrenheit, of global warming, and 10% at 3.2 degrees Celsius, 5.8 degrees Fahrenheit. 99. In worst-case scenarios, half of all tree species may be driven extinct by climate change over that timeframe. 95. Freshwater species. Freshwater ecosystems such as swamps, deltas, and rivers make up 1% of Earth's surface. They are important because they are home to approximately one-third of vertebrate species. 100 freshwater species are beginning to decline at twice the rate of species that live on land or in the ocean. This rapid loss has already placed 27% of 29,500 species dependent on freshwater on the IUCN Red List. 100. Global populations of freshwater fish are collapsing due to water pollution and overfishing. Migratory fish populations have declined by 76% since 1970, and large, megafish, populations have fallen by 94% with 16 species declared extinct in 2020. 101. Marine species. Marine biodiversity encompasses any living organism that resides in the ocean or in estuaries. 102. By 2018, approximately 240,000 marine species had been documented. 100. Many marine species, estimates range between 178,000 and 10 million oceanic species, remain to be described. 102. It is therefore likely that a number of rare species, not seen for decades in the wild, 100 species, not 103. But many marine species, estimates range between 178,000 and 10 million oceanic species, remain to be described. 102. It is therefore likely that a number of rare species, not seen for decades in the wild, have already disappeared or are on the brink of extinction, unnoticed. 104. Human activities have a strong and detrimental influence on marine biodiversity. The main drivers of marine species extinction are habitat loss, pollution, invasive species, and overexploitation. 105. 106. Greater pressure is placed on marine ecosystems near coastal areas because of the human settlements in those areas. 107. Overexploitation has resulted in the extinction of over 25 marine species. This includes seabirds, marine mammals, algae, and fish. 102. 108. Examples of extinct marine species include Steller's sea cow, Hydrodomalus gigas, and the Caribbean monk seal, Monachus tropicalis. Not all extinctions are because of humans. For example, in the 1930s, the eelgrass limpet, Ladia alveus, became extinct in the Atlantic once the Zostera marina seagrass population declined upon exposure to a disease. 109. The Ladia alveus were greatly impacted because the Zostera marina were their sole habitat. 102. Causes. The main causes of current biodiversity loss are 1. Habitat loss, fragmentation and degradation. 4. For example, habitat fragmentation for commercial and agricultural uses, specifically monoculture farming. 5. 2. Land use intensification and ensuing land loss, habitat loss, a significant factor in loss of ecological services due to direct effects as well as biodiversity loss. 6. 3. Nutrient pollution and other forms of pollution, air and water pollution. 4. Overexploitation and unsustainable use, for example unsustainable fishing methods, overfishing, overconsumption and human overpopulation. 5. And species that effectively compete for a niche, replacing indigenous species. 7. 6. Climate change, e.g. extinction risk from climate change, effects of climate change on plant biodiversity. 4. Diamond describes an evil quartet of habitat destruction, overkill, introduced species and secondary extinctions. 100. Edward O. Wilson suggested the acronym HIPPO for the main causes of biodiversity loss: habitat destruction, invasive species, pollution, human overpopulation and overharvesting. 111. 112. Habitat destruction. Earth's 25 terrestrial hotspots of biodiversity. These contain a high number of plant and animal species and have been subjected to high levels of habitat destruction by human activity, leading to biodiversity loss. And increased road building in the Amazon rainforest in Bolivia cause significant concern because of increased human encroachment upon wild areas, increased resource extraction and further threats to biodiversity. Habitat destruction, also termed habitat loss and habitat reduction, occurs when a natural habitat is no longer able to support its native species. The organisms once living there have either moved elsewhere or are dead, leading to a decrease in biodiversity and species numbers. 113. 114. Habitat destruction is in fact the leading cause of biodiversity loss and species extinction worldwide. 115. Humans contribute to habitat destruction through the use of natural resources, agriculture, industrial production and urbanization, urban sprawl. Other activities include mining, logging and trawling. Environmental factors can contribute to habitat destruction more indirectly. Geological processes, climate change. 114. Introduction of invasive species, ecosystem nutrient depletion, water and noise pollution are some examples. Loss of habitat can be preceded by an initial habitat fragmentation. Fragmentation and loss of habitat have become one of the most important topics of research in ecology as they are major threats to the survival of endangered species. 116. For example, habitat loss is one of the causes in the decline of insect populations. See the section below on insects. Urban growth and habitat fragmentation. Direct effects of urban growth on habitat loss are well understood. Building construction often results in habitat destruction and fragmentation. 117. This leads to selection for species that are adapted to urban environments. 118. Small habitat patches cannot support the level of genetic or taxonomic diversity they formerly could, while some more sensitive species may become locally extinct. 119. Species abundance populations are reduced due to the reduced fragmented area of habitat. This causes an increase of species isolation and forces species toward edge habitats and to adapt to foraging elsewhere. 117. Infrastructure development in key biodiversity areas, KBA, is a major driver of biodiversity loss, with infrastructure present in roughly 80% of KBAs. 120. Infrastructure development leads to conversion and fragmentation of natural habitat, pollution and disturbance. There can also be direct harm to animals through collisions with vehicles and structures. This can have impacts beyond the infrastructure site. 120. Land use intensification. Humans are changing the uses of land in various ways, and each can lead to habitat destruction and biodiversity loss. 2019 Global Assessment Report on Biodiversity and Ecosystem Services found that industrial agriculture is the primary driver of biodiversity collapse. 21.8 The UN's Global Biodiversity Outlook 2014 estimated that 70% of the projected loss of terrestrial biodiversity is caused by agriculture use. According to a 2005 publication, cultivated systems cover 24% of Earth's surface. 122 When the publication defined cultivated areas as areas in which at least 30% of the landscape is in croplands, shifting cultivation, confined livestock production, or freshwater aquaculture in any particular year. 122, 51. 17,000 species are at risk of losing habitat by 2050 as agriculture continues to expand to meet future food needs, as of 2020. 123. A global shift toward largely plant-based diets would free up land to allow for the restoration of ecosystems and biodiversity. 124. In the 2010s over 80% of all global farmland was used to rear animals. 124. 2022, 44% of Earth's land area required conservation attention, which may include declaring protected areas and following land use policies. 125. Nutrient pollution and other forms of pollution. Air pollution. Air pollution. Industrial processes contributing to air pollution through the emission of carbon dioxide, sulfur dioxide, and nitrous oxide. Air pollution adversely affects biodiversity. 126. Pollutants are emitted into the atmosphere by the burning of fossil fuels and biomass, for example. Industrial and agricultural activity releases the pollutants sulfur dioxide and nitrogen oxides. Once sulfur dioxide and nitrogen oxide are introduced into the atmosphere, they can react with cloud droplets, cloud condensation nuclei, raindrops, or snowflakes, forming sulfuric acid and nitric acid. With the interaction between water droplets and sulfuric and nitric acids, wet deposition occurs and creates acid rain. 108, 129, a 2009 review studied 4 air pollutants, sulfur, nitrogen, ozone, and mercury, and several types of ecosystems. 130. Air pollution affects the functioning and biodiversity of terrestrial as well as aquatic ecosystems. 30. For example, air pollution causes or contributes to acidification of lakes, eutrophication of estuaries and coastal waters, and mercury bioaccumulation in aquatic food webs. 130. Noise pollution. Noise generated by traffic, ships, vehicles, and aircraft can affect the survivability of wildlife species and can reach undisturbed habitats. 131. Noise pollution is common in marine ecosystems, affecting at least 55 marine species. 132. One study found that as seismic noises and naval sonar increases in marine ecosystems, cetacean diversity decreases, including whales and dolphins. 130. Multiple studies have found that fewer fishes, such as cod, haddock, rockfish, herring, sand seal, and blue whiting, have been spotted in areas with seismic noises, with catch rates declining by 40. 80%. 132, 134, 135, 136. Noise pollution has also altered avian communities and diversity. Noise can reduce reproductive success, minimize nesting areas, increase stress response, and reduce species abundance. 137, 132. Noise pollution can alter the distribution and abundance of prey species, which can then impact predator populations. 138. Pollution from fossil fuel extraction. Fossil fuel extraction. Proportions of oil and gas field area overlapping with protected areas gray polygons, of different IUCN protected area management categories by UN regions. North America, Europe B, West Asia C, LAC D, Africa E, and Asia Pacific F. Absolute area of overlap across all IUCN management categories is shown above histograms. Location of fields overlapping with PAR shown in G. So that points can be visualized even where their spatial locations coincide, so darker points indicate higher densities of fields overlapping PA. 139. Fossil fuel extraction and associated oil and gas pipelines have major impacts on the biodiversity of many biomes due to land conversion, habitat loss and degradation, and pollution. An example is the western Amazon region. 140. Exploitation of fossil fuels there has had significant impacts on biodiversity. As of 2018, many of the protected areas with rich biodiversity were in areas containing unexploited fossil fuel reserves worth between $3 and $15 trillion. 139. The protected areas may be under threat in future. Overexploitation. Continued overexploitation can lead to the destruction of the resource, as it will be unable to replenish. The term applies to natural resources such as water aquifers, grazing pastures and forests, wild medicinal plants, fish stocks and other wildlife. Overfishing. Mass fishing of Pacific jack mackerel with possible bycatch with a Chilean purse seiner. Atlantic cod stocks were severely overexploited in the 1970s and 1980s, leading to their abrupt collapse in 1992. 141. A 2018 Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services report found that overfishing is the main driver of mass species extinction in oceans. 142. 143. Overfishing has reduced fish and marine mammal biomass by 60% since the 1800s. 144. It is currently pushing over one-third of sharks and rays toward extinction. 145. Many commercial fishes have been overharvested. A 2020 FAO report classified as overfished 34% of the fish stocks of the world's marine fisheries. 146. By 2020, global fish populations had declined 38% since 1970. 103. Many regulatory measures are available for controlling overfishing. Include fishing quotas, bag limits, licensing, closed seasons, size limits, and the creation of marine reserves and other marine protected areas. Human overpopulation and overconsumption. The changing distribution of the world's land mammals in tons of carbon. The biomass of wild land mammals has declined by 85% since the emergence of humans. 147. World population numbered nearly 7.6 billion as of mid-2017 and is forecast to peak toward the end of the 21st century at 10 to 12 billion people. 48. Scholars have argued that population size and growth, along with overconsumption, are significant factors in biodiversity loss and soil degradation. 149, 150, 111 review articles, including the 2019 IPBES report, have also noted that human population growth and overconsumption are significant drivers of species decline. A 2022 study warned that conservation efforts will continue to fail if the primary drivers of biodiversity loss continue to be ignored, including population size and growth. 10. Scientists have criticized the assertion that population growth is a key driver for biodiversity loss. Argue that the main driver is the loss of habitat, caused by the growth of commodities for export, particularly soybean and oil palm, primarily for livestock feed or biofuel consumption in higher income economies. 13. Because of the wealth disparities between countries, there is a negative correlation between a country's total population and its per capita footprint. On the other hand, the correlation between a country's GDP and its footprint is strong. 13. The study argues that population as a metric is unhelpful and counterproductive for tackling environmental challenges. 13. Invasive species. The term invasive is poorly defined and often very subjective. 51. The European Union defines invasive alien species as those outside their natural distribution area that threaten biological diversity. 102. 153. Biotic invasion is considered one of the 5 top drivers of global biodiversity loss and is increasing because of tourism and globalization. 154. 155. This may be particularly true in poorly regulated freshwater systems, though quarantines and ballast water rules have improved the situation. 122. Native species may drive local native species to extinction via competitive exclusion, niche displacement, or hybridization with related native species. Therefore, alien invasions may result in extensive changes in the structure, composition and global distribution of the biota at sites of introduction. This leads to the homogenization of the world's fauna and flora and biodiversity. Loss. 156. 157. Climate change. Between the magnitude of climate variability and change, including both large increases and decreases in global temperature, and the extinction rate, over the past 450 million years. 158. This graph does not include the recent human-made climate change. Climate change is another threat to global biodiversity. 14. 15. But habitat destruction, e.g., for the expansion of agriculture, is currently a more significant driver of biodiversity loss. 18. 19. A 2021 collaborative report by scientists from the IPBES and the IPCC found that biodiversity loss and climate change must be addressed simultaneously, as they are inextricably linked and have similar effects on human well-being. 159. In 2022, Frans Timmermans, Vice President of the European Commission, said that people are less aware of the threat of biodiversity loss than they are of the threat of climate change. 160. The interaction between climate change and invasive species is complex and not easy to assess. Climate change is likely to favor some invasive species and harm others. 161, but few authors have identified specific consequences of climate change for invasive species. 162. Invasive species and other disturbances have become more common in forests in the last several decades. These tend to be directly or indirectly connected to climate change and have negative consequences for forest ecosystems. 2021. Decline in Arctic sea ice extent area from 1979 to 2022. Decline in Arctic sea ice volume from 1979 to 2022. Climate change contributes to destruction of some habitats, endangering various species. For example, climate change causes rising sea levels which will threaten natural habitats and species. Globally, 163, 164. Melting sea ice destroys habitat for some species. 160,321 For example, the decline of sea ice in the Arctic has been accelerating during the early 21st century, with a decline rate of 4.7% per decade. It has declined over 50% since the first satellite records. 166, 167, 168 One well-known example of a species affected is the polar bear, whose habitat in the Arctic is threatened. 169 Algae can also be affected when it grows on the underside of sea ice. 170. Warm water coral reefs are very sensitive to global warming and ocean acidification. Coral reefs provide a habitat for thousands of species. They provide ecosystem services such as coastal protection and food. 70–90% of today's warm water coral reefs will disappear even if warming is kept to 1.5 degrees Celsius, 2.7 degrees Fahrenheit. 101, 179 For example, Caribbean coral reefs, which are biodiversity hotspots, will be lost within a century if global warming continues at the current rate. 172. Extinction risks. The impact of 3 different climate change scenarios on local biodiversity and risk of extinction of vertebrate species. 173. There are several plausible pathways that could lead to an increased extinction risk from climate change. Every plant and animal species has evolved to exist within a certain ecological niche. 174 But climate change leads to changes of temperature and average weather patterns. 175, 176 These changes can push climatic conditions outside of the species niche, and ultimately render it extinct. 177 Normally, species faced with changing conditions can either adapt in place through microevolution or move to another habitat with suitable conditions. However, the speed of recent climate change is very fast. Due to this rapid change, for example, ectotherm cold-blooded animals, a category which includes amphibians, reptiles and all invertebrates, may struggle to find a suitable habitat within 50 kilometers of their current location at the end of this century for a mid-range scenario of future global warming. 178. Climate also increases both the frequency and intensity of extreme weather events. 179 Which can directly wipe out regional populations of species. 180 Those species occupying coastal and low-lying island habitats can also become extinct by sea level rise. This has already happened with Bramble Cay melomys in Australia. 181 Finally, climate change has been linked with the increased prevalence and global spread of certain diseases affecting wildlife. This includes Trachochytrium dendrobatitis, a fungus that is one of the main drivers of the worldwide decline in amphibian populations. 182. Impacts on ecosystems. Biodiversity loss has bad effects on the functioning of ecosystems. 45 Because affected ecosystems can no longer provide the same quality of ecosystem services, such as crop pollination, cleaning air and water, decomposing waste, and providing forest products as well as areas for recreation and tourism. 122. Two statements of a 2012 comprehensive review of the previous 20 years of research include. 45. There is now unequivocal evidence that biodiversity loss reduces the efficiency by which ecological communities capture biologically essential resources, produce biomass, decompose and recycle biologically essential nutrients, and impacts of diversity loss on ecological processes might be sufficiently large to rival the impacts of many other global drivers of environmental change. Permanent global species loss, extinction, is a more dramatic phenomenon than regional changes in species composition. But even minor changes from a healthy stable state can have a dramatic influence on the food web and the food chain, because reductions in one species can adversely affect the entire chain. CO extinction. This can lead to an overall reduction in biodiversity, unless alternative stable states of the ecosystem are possible. 183. Example, a study on grasslands used manipulated grassland plant diversity and found that ecosystems with higher biodiversity show more resistance of their productivity to climate extreme. 184. On food and agriculture. An infographic describing the relationship between biodiversity and food. In 2019, the UN's Food and Agriculture Organization, FAO, produced its first report on the state of the world's biodiversity for food and agriculture. It warned that many key components of biodiversity for food and agriculture at genetic, species and ecosystem levels are in decline. 185, 186. Report also said, many of the drivers that have negative impacts on BFA, biodiversity for food and agriculture, including overexploitation, overharvesting, pollution, overuse of external inputs, and changes in land and water management, are at least partially caused by inappropriate agricultural practices. 187, 6 and transition to intensive production of a reduced number of species, breeds and varieties, remain major drivers of loss of BFA and ecosystem services. 187, 6. Biodiversity loss related to agricultural practices. FAO encourages the use of biodiversity-friendly management practices in crop and livestock production, forestry, fisheries and aquaculture. 187, 13. On health and medicines. WHO has analyzed how biodiversity and human health are connected. Biodiversity and human health, and the respective policies and activities, are interlinked in various ways. First, biodiversity gives rise to health benefits. For example, the variety of species and genotypes provide nutrients and medicines. 188. The ongoing drivers and effects of biodiversity loss has the potential to lead to future zoonotic disease outbreaks like the COVID-19 pandemic. 189. Medicinal and aromatic plants are widely used in traditional medicine as well as in cosmetic and food industries. 188. 12. The WHO estimated in 2015 that about 60,000 species are used for their medicinal, nutritional and aromatic properties. 188. 12. There is a global trade in plants for medicinal purposes. 188. 12. Biodiversity contributes to the development of pharmaceuticals. A significant proportion of medicines are derived from natural products, either directly or indirectly. Many of these natural products come from marine ecosystems. 190. However, unregulated and inappropriate overharvesting, bioprospecting, could potentially lead to overexploitation, ecosystem degradation and loss of biodiversity. 191. 192. Users and traders harvest plants for traditional medicine either by planting them or by collecting them in the wild. In both cases, sustainable medicinal resource management is important. 188. 13. Proposed solutions. 2019, the Red List Index (RLI) defines the conservation status of major species groups, and measures trends in the proportion of species expected to remain extant in the near future without additional conservation action. RLI value of 1.0 equates to all species being categorized as least concern, and hence that none are expected to go extinct in the near future. A value of 0 indicates that all species have gone extinct. 193. Scientists are investigating what can be done to address biodiversity loss and climate change together. For both of these crises, there is a need to conserve enough nature and in the right places. 2020 study found that, beyond the 15% land area currently protected, 35% of land area is needed to conserve additional sites of particular importance for biodiversity and stabilize the climate. 194. Additional measures for protecting biodiversity, beyond just environmental protection, are important. Such measures include addressing drivers of land use change, increasing efficiency in agriculture, and reducing the need for animal agriculture. The latter could be achieved by increasing the shares of plant-based diets. 195. 196. Convention on Biological Diversity. Governments have conserved portions of their territories under the Convention on Biological Diversity, CBD, a multilateral treaty signed in 1992-3. The Aichi biodiversity targets are part of the CBD's Strategic Plan 2011-2020 and were published in 2010. 197. Aichi Target Number 11 aimed to protect 17% of terrestrial and inland water areas and 10% of coastal and marine areas by 2020. 198. Any biodiversity goals laid out by the Aichi biodiversity targets in 2010, only 6 were partially achieved by 2020. 23. 2020 CBD report highlighted that if the status quo does not change, biodiversity will continue to decline due to currently unsustainable patterns of production and consumption, population growth and technological developments. 199. 200. The report also singled out Australia, Brazil, Cameroon and the Galapagos Islands, Ecuador, for having had one of its animals lost to extinction in the previous 10 years. 201. Following this, the leaders of 64 nations and the European Union pledged to halt environmental degradation and restore the natural world. Pledge not signed by leaders from some of the world's biggest polluters, namely China, India, Russia, Brazil and the United States. 202. Some experts contend that the United States' refusal to ratify the Convention on Biological Diversity is harming global efforts to halt the extinction crisis. 203. Scientists say that even if the targets for 2020 had been met, no substantial reduction of extinction rates would likely have resulted. 150. Others have raised concerns that the Convention on Biological Diversity does not go far enough, and argue the goal should be 0 extinctions by 2050, along with cutting the impact of unsustainable food production on nature by half. That the targets are not legally binding has also been subject to criticism. 204. In December 2022, every country except the United States and the Holy See, 205, signed on to the Kunming-Montreal Global Biodiversity Framework at the 2022 United Nations Biodiversity Conference. This framework calls for protecting 30% of land and oceans by 2030, 30 by 30. Also has 22 other targets intended to reduce biodiversity loss. At the time of signing the agreement, only 17% of land territory and 10% of ocean territory were protected. The Agreement in protecting the rights of indigenous peoples and changing the current subsidy policy to one better for biodiversity protection, but it takes a step backward in protecting species from extinction in comparison to the Aichi targets. 207 Critics said the agreement does not go far enough to protect biodiversity, and that the process was rushed. 206 Other international and national action. In 2019, Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, IPBES, published the Global Assessment Report on Biodiversity and Ecosystem Services. This report said that up to 1 million plant and animal species are facing extinction because of human activity. The IPBES is an international organization that has a similar role to the Intergovernmental Panel on Climate Change, IPCC, 208, except that it focuses on biodiversity and ecosystem services, not climate change. The United Nations Sustainable Development Goal 15 Sudanese pounds, life on land, includes biodiversity targets. Target is, take urgent and significant action to reduce the degradation of natural habitats, halt the loss of biodiversity and, by 2020, protect and prevent the extinction of threatened species. 209 This target has one indicator, the Red List Index. 210 Nearly 3/4 of bird species, 2/3 of mammals and more than half of hard corals have been recorded at World Heritage Sites, even though they cover less than 1% of the planet. Countries with World Heritage Sites can include them in their national biodiversity strategies in action. Planned ecological extinction. Ecological extinction is the reduction of a species to such low abundance that, although it is still present in the community, it no longer interacts significantly with other species. One ecological extinction stands out because it is the interaction ecology of a species that is important for conservation work. They state that, unless the species interacts significantly with other species in the community, e.g. it is an important predator, competitor, symbiont, mutualist, or prey, its loss may result in little to no adjustment to the abundance and population structure of other species. 1. This view stems from the neutral model of communities that assumes there is little to no interaction within species unless otherwise proven. Estes, Duggins, and Rathburn 1989 recognize two other distinct types of extinction. Global extinction is defined as the ubiquitous disappearance of a species. Local extinction is characterized by the disappearance of a species from part of its natural range. 1. Keystone species. This view stems from the neutral model of communities that assumes there is little to no interaction within species unless otherwise proven. Estes, Duggins, and Rathburn 1989 recognize two other distinct types of extinction. Global extinction is defined as the ubiquitous disappearance of a species. 1. Local extinction is characterized by the disappearance of a species from part of its natural range. 1. Keystone species. Payne first established the concept of a keystone species by studying the sea star. Payne 1969 first came up with the concept of a keystone species while studying the effects of the predatory sea star Pisister acraceus on the abundance of the herbivorous gastropod, Tegula funabralis. This took place in the rocky intertidal habitat off the coast of Washington. Payne removed all Pisister in 8 meters by 10 meters plots weekly while noting the response of Tegula for 2 years. He found that removing the top predator, in this case being Pisister, reduced species number in the treatment plots. The concept of a keystone species is a species that has a disproportionate effect on the community structure of an environment in relation to its total biomass. This keystone species effect forms the basis for the concept of ecological extinction. 2. Examples. Sea otters maintain the overall biodiversity of the kelp forest community. The role of the sea otter as the keystone predator in nearshore kelp forests was evaluated by Estes et al. In a 1978 study. They paired the rat in near islands in the Aleutian Islands to test if sea otter predation controls epibenthic invertebrate populations, specifically sea urchins. Undine Turn releases the vegetation association from intense grazing. 3. Estes and his found that different size structures and densities of sea urchins were correlated with the presence of sea otter populations, and because they are the principal prey of this keystone predator, the sea otters were most likely the main determinants of the differences in sea urchin populations. With high sea otter densities, the herbivora of sea urchins in these kelp forests was severely limited, and this made competition between algal species the main determinant in survival. However, when sea otters were absent, herbivora of the sea urchins was greatly intensified to the point of decimation of the kelp forest community. This loss of heterogeneity serves as a loss of habitat for both fish and eagle populations that depend on the richly productive kelp forest environment. Total overharvesting of sea otter furs has severely restricted their once wide-ranging habitat, and only today are scientists starting to see the implications of these local extinctions. 3. California spiny lobster, or Panulirus interruptus, is a keystone predator that has a distinct role in maintaining species diversity in its habitat. Robles 1987 demonstrated experimentally that the exclusion of spiny lobsters from the intertidal zone habitats led to the competitive dominance of mussels, Mytilus edulis and M. californianus. This result shows another example of how the ecological extinction of a keystone predator can reduce species diversity in an ecosystem. The threshold of ecological extinction has passed due to overfishing, so that local extinctions of the California spiny lobster are common. 4. Commercial oyster fishing had not affected the Chesapeake Bay ecosystem until mechanical dredges were utilized in the 1870s, resulting in overfishing of the oysters. Today is plagued by eutrophication due to algal blooms, and the resulting water is highly hypoxic. competitively excluded any other species from surviving, including the rich diversity in faunal life that once flourished, such as dolphins, manatees, river otters, sea turtles, alligators, sharks, and rays. This highlights the top-down loss of diversity commercial fishing has on marine ecosystems by removing the keystone species of the environment. 5. Invasive species. The potential ecological extinction of guanacos, llama guanico, and Lesser Rheas pterocnemia pinnata, as a prey source for native omnivores and predators in the Argentine Patagonia was assessed by a study by Novaro in 2000. These native species are replaced by introduced species such as the European rabbit, red deer, and domestic cattle. The cumulative damage from the increased herbivora by introduced species has also served to accelerate destruction of the already dwindling Argentine pampas and steppe habitats. This was the first study to take into account a large number of diverse predators, ranging from skunks to pumas, as well as conduct their survey in non-protected areas that represent the majority of southern South America. Novaro and his colleagues found that the entire assemblage of native carnivores relied primarily on introduced species as a prey base. They also suggested that the Lesser Rhea and guanaco had already passed their ecological effective density as a prey species, and thus were ecologically extinct. It is possible that the niches of introduced species as herbivores too closely mirrored those of the natives, and thus competition was the primary cause of ecological extinction. The effective introduction of new competitors, such as the red deer and rabbit, also served to alter the vegetation in the habitat, which could have further pronounced the intensity of competition. And rheas have been classified as a low risk for global extinction, but this simplistic view of their demography does not take into account that they have already become functionally extinct in the Argentine Patagonia. Novaro and his colleagues suggest this loss could have strong effects on plant-animal interactions, nutrient dynamics, and disturbance regimes. SIC is an example of how current conservation policy has failed to protect the intended species because of its lack of a functionally sound definition for extinction. 6. Christian found Argentine ants to disrupt large seed dispersal mutualisms. Seed dispersal mechanisms play a fundamental role in the regeneration and continuation of community structure, and a recent study by Christian, 2001, demonstrated a shift in the composition of the plant community in the South African shrublands following an invasion by the Argentine ant, Leinpithema humile. Ants are 30% of the flora in the shrublands and are vital to the survival of fynbos plants because they bury the large seeds away from the dangers of predation and fire damage. It is also crucial for seeds to be buried, because nearly all seed germination takes place in the first season after a fire. Argentine ants, a recent invader, do not disperse even small seeds. Christian tested whether the invasion of the Argentine ant differentially affected small and large-seeded fauna. He found that post-fire recruitment of large-seeded flora was reduced disproportionately for large seeds in sites already invaded by Argentine ants. These initial low large seed density recruitments will eventually lead the domination of small-seeded fauna in invaded habitats. Consequences of this change in community structure highlight the struggle for dispersal of large-seeded flora that have potential reverberations around the world because ants are major ecological seed dispersers throughout the globe. 7. Modeling ecological extinction. Below a certain density threshold, flying foxes are no longer effective seed dispersers. McConkie and Drake 2006 study is unique because it was one of the first attempts to model a density-dependent threshold relationship that described ecological extinction. Studied a seed dispersal interaction between flying foxes and trees with large seeds on the tropical Pacific islands. Insular flying foxes, Pteropus tonginus, are considered to be keystone species because they are the only seed dispersers that can carry large seeds long distances. The pathogen model by Janssen and Connell suggests that survivorship of seeds in the tropics greatly increases the further away from the parent tree it lands, and that trees require this dispersal in order to avoid extinction. In the pathogen-laden environment of the tropics, seed dispersal only becomes more paramount to species survival. As hypothesized, McConkie and Drake found a threshold relationship between the flying fox index, FFI, and the median proportion of seeds carried over 5 meters. Below the threshold, seed dispersal was insignificant and independent of flying fox abundance. However, above the threshold, dispersal positively correlated with increased flying fox abundance, as measured by the FFI. Although they did not directly prove the cause for this relationship, McConkie and Drake propose a behavioral mechanism. Flying foxes are known to be territorial, and in the absence of competition a flying fox will eat within one tree, effectively dropping the seeds right below it. Alternatively, if there is a high density of flying foxes feeding at one time, abundance above the threshold density, then aggressive behavior, such as stealing fruit from another individual's territory, will lead to longer average seed dispersal. In this way, the seed dispersing flying fox has a disproportional effect on the overall community structure in comparison to their relative biomass. The effect of ecological extinction on communities is the first step to applying this framework into conservation work. 8. While ecologists are just starting to get a grapple on the significant interactions within an ecosystem, they must continue to find an effective density threshold that can maintain the level of equilibrium species diversity. Only with this knowledge of where and to what extent a specific species interacts with its environment will the proper and most efficient levels of conservation work take place. This work is especially important on the limited ecosystems of islands, where there are less likely to be replacement species for specific niches. With diversity and available habitat decreasing rapidly worldwide, identifying the systems that are most crucial to the ecosystem will be the crux of conservation work. 8. Climate change. Climate change has produced numerous shifts in the distributions and abundances of species. Thomas et al. 2004 went on to assess the extinction risk due to these shifts over a broad range of global habitats. Predictive model using midline estimates for climate warming over the next 50 years suggests that 15 to 37% of species will be committed to extinction by 2050. Although the global temperature has risen 0.6 degrees Celsius, individual populations and habitats will only respond to their local changes in climate. 9. Root et al. 2002 suggests that local changes in climate may account for density changes in regions, shifts in phenology timing of events, changes in morphology biology, such as body size, and shifts in genetic frequencies. They found that there have been an average phenological shift of 5.1 days earlier in the spring for a broad range of over 1,000 compiled studies. This was also, as predicted, more pronounced in the upper latitudes that have concurrently had the largest shift in local average temperatures. 10. Algal habitat, loss of pollinator mutualisms, and the effect of introduced species all have distinct pressures on native populations. These effects must be looked underneath a synergistic and not an independent framework.